Hello everyone, in this video we're going to talk about Ecology Lecture 6. The first question that we want to talk about is what is a climate? So if you look right here, a climate is an average condition over a long period of time, right? A climate could be a place that has a lot of droughts, a place that has a lot of rain, a place that's really hot all the time. That is climate, and climate is dependent on all these factors: solar energy, latitude, transport of heat by wind, and ocean currents, right? If you look at a map of the world, you can see that different part of the world, depending on how close you are to the pole, what your latitude is, and how far you are away from water or the two poles, it will affect the overall climate, the overall temperature of this area. Weather, however, is short-lived. Weather is not an average. Weather is something that's happening right now, and it changes. It could change potentially very fast, and it changes every day for sure, right? The next one is greenhouse gases. You first need to know what greenhouse gases are. Greenhouse gases, a lot of time when we think about it, we think about CO2. But CO2 is not the only type of greenhouse gases. There's also methane, and there's also water vapor. All of those gas in the air trap heat, so they're kind of like a greenhouse. Right? If you think about a greenhouse, that's for you to grow plants that need a lot of heat, and we're trapping the heat. And a question could ask you, does greenhouse gases exist even without the existence of human beings? The answer would be yes, because there has always been water vapor, right? For a long time where the Earth existed, we had water. And then carbon dioxide and methane was also something that was already in the atmosphere. So greenhouse gases have always been there, but if you watched the last video, you would know that what human beings are doing is that we're increasing the greenhouse gases by a whole lot, and the result is we're trapping a lot more heat than we would normally, right? So then there will be climate change, and that is not good because it's ruining everything. So the next one is the definition of a population. By this point, so excited about population. By this point, you have to know what population is, right? A population is one species, individuals of one species, the same species living in the same area. So you would not consider all of the tigers in America. You would consider all the tigers in, I don't know, a part of America. I don't know. I don't even know what part of America actually has tigers, but you get it. Let's say Arizona has tigers. All the tigers in 30 acres of land of Arizona would have tigers. I think that's so wrong, but you get it. It's one species in a certain area. The next one, whenever you're talking about a population, it's much easier to talk about people, right? Then you can talk about size, density, and dispersion, which are properties of population. So then you can have a better discussion on what are some characteristics of your population. So for example, we could say the population of Georgetown Prep is about 600 people, okay? That would be your population size. How many individuals do we have? How many individuals do we have at Georgetown Prep? There are about 600 individuals. So that's population size. Population density, however, you need to know the difference between density and size. The size is just the individuals. The density is how compact everything is, right? If you think about a classroom, it's quite compact. But if you think about, let's say, after school, the people are more dispersed. So then you can consider the density. How dense is the people at Georgetown Prep? So then you could say 400 people per, I don't know what it is, 400 people per 20 acres of land, for example. That would be your density. So I'm going to write this down actually, because you need to know, you're going to put numbers of person first, and then use that number to divide by the acre of land or whatever, square meter, whatever area that you have. So you could have 400 people, wait, supposed to be 600. 600 people per 20 acre. It's so wrong, but you get the idea. So if you do this mathematically, you're going to get a number 30. And you can't just write 30. If you just write 30, I will not give you even half a point. Hear me out right now. Do not just write 30. Because if you write 30, how am I supposed to know what it is? 30 hot dogs? 30 what? It should be 30 people per acre. You have to write the units. If you don't write the units, I don't know what you're talking about. And then you could talk about, let's say a restaurant. You could say there are 20 people in half an acre. Just making this up right now. Then the answer would be 40 people. Again, you cannot just write 40 because I'm going to assume that you're talking about hot dogs, and that's not the right answer. And then it's 40 people per acre, right? If you compare these numbers, you're actually reducing the front part and then reduce the second part to just 1. If you know how to do the math. If you do not know, please ask your math teacher or come ask me on Wednesday after school. But in this case, which population is more dense? You could talk about population size. The population size is higher at Georgetown Prep, 600 people, but the population density, how compact your population is at this restaurant. 40 people per acre is a lot more dense than 38 people per acre. So make sure you know how to calculate this, how to compare population density, and know that you have to write the units. The next one is dispersion. Dispersion, we have, that's how spread out your individual are, and what is the orientation of all these individuals within your population. So here we have three different types of dispersion. We have clumped, you have little clumps, right? This is clumped. You have uniform, so you don't have to have straight rows and columns, but if each individual is spaced out the same way, then you would call that uniform. The third one is random. If everything is random, that's random. Okay? So make sure you understand dispersion is talking about kind of where is each individual placed within the population. Obviously, the dispersion doesn't always stay the same, right? But in general, they're about the same. But then population density, you have to know what it is. It's how compact are these individuals within the population. The next one is The next one is population growth. So population growth is, first off, is your population growing or not? And you can consider a few factors. You consider birth, death, immigration, and emigration. So birth and death, that's easy. If you have higher birth than death, then your population is going to increase. If you have higher death than birth, your population is going to decrease. If you have immigration, remember immigration is coming in, then your population is going to grow. If you have higher immigration than emigration, your population is going to grow. If you have emigration, people going out, then your population is going to be reduced. But you have to compare all four of these factors, right? If you add all the birth, add all the immigration minus the death and the emigration, then you'll get how your population is growing. The next one is biotic potential. Biotic potential is one definition that you kind of have to memorize a little bit. So biotic potential is the maximum rate at which a population could increase under ideal conditions. So this kind of goes hand in hand with our exponential growth. Remember, exponential growth is the population that just keeps on growing. Biotic potential is kind of the same idea. If you have an ideal condition, meaning there's no predator, no disease, no lack of resources, and the result is the maximum rate of population increase. How fast can your population increase under this ideal condition? Next one, okay, we're just talking about exponential growth. Let's find a picture. Okay, so right here, if you just, right here. So this is a picture of exponential growth. I'm going to make it big. Exponential growth is your population growth rate keeps on getting faster and faster. Your population keeps growing faster. Your population keeps growing, and it just keeps on getting faster, okay? This is exponential growth. That means there's no, see, look, it says no predator, no parasite, no competition, no immigration, no immigration. There is unlimited resources. There is, it usually happens when a population is first introduced. This does not happen very often, okay? So again, we mentioned this in class already, but you need to kind of understand it. Whenever you see this, right, you see what a question is asking, and then you want to draw an arrow up or down. Is the question asking for something that allows your population to grow really fast, or is it asking you your population is growing slow? So then you can look at the answer choices and kind of determine, is this factor increasing my population or is it decreasing my population? So for example, if you say no predation, that's increase of population. But if you say there are a lot of predators, then that will be decrease of population. Sorry. So you draw a downward arrow that way. Okay. So make sure you're reading questions really carefully and drawing those arrows to help you understand what the question is asking and what the answers are saying. Okay. So again, exponential growth. Here's a definition. Nope, there's not a definition here. Okay. Exponential growth is basically your population is growing unlimitedly. It just keeps growing and growing faster and faster. Carrying capacity. Carrying capacity is right here. A carrying capacity is the limit to the number of individuals that can actually occupy one area at a particular time. So instead of your population keeps on growing faster and faster and just keeps going, eventually it reaches a certain carrying capacity. That's how many individuals your environment, your little habitat can actually carry. Around how many individuals can your habitat actually endure, right? If you go more above that, if you go above that, you will have an overshoot, but there are other factors that will eventually come in and limit the population growth. So you start off with a fast, very high rate of population growth, and then it kind of slows down, and then it's kept about the same. So the line where it's kept about the same, in this case, it's about 1.6 million is going to be your answer for what the carrying capacity is in this case. And then you should know that human population growth is kind of an exponential growth. It's kind of slowing down a little bit, but we're not quite there yet. It's important for you to remember, even when we're slowing down, right? Even when we kind of reaches this point, your population could still be growing, right? If you see right here, it's kind of slowing down a little bit, but your population is still growing. Our human population is still growing, but the rate of population increase is kind of slowing down, okay? And if you have a curve that looks like this, instead of a J curve, you kind of have an S curve, you will call this logistic growth. So I'm going to write this right here, since I forgot to write it. Logistic growth. So you should be able to look at a picture and identify exponential growth, logistic growth, carrying capacity, the exponential growth phase of a logistic growth, which is right here. Carrying capacity, right here. You will look at the y-axis, that's the carrying capacity. Okay? This is it. Good luck.